Good morning, ShmooCon. How are you doing this morning? Good turnout for a Saturday morning. Hopefully Sunday morning turnout's just as well. The only thing I want to mention, when you're out of here, feel free to swing by Reg. We have t-shirts for sale, bags of crap, lots of wonderful stuff for sale. Feel free to swing by. That's all open. But the first talk we're going to present this morning is Andrew Morris. He's been scanning the internet, looking at things, trying to figure out what's going on out there. I'm going to talk about kind of that gray noise, the background noise of the internet. So let's give a round of applause for Andrew.
Thank you so much, everybody. Thanks for coming out. I'm really, really excited to give this talk. It's called The Background Noise of the Internet. I've been wanting to give this talk for a very, very long time. So I have a just ridiculous amount of content, so I might go a little bit quickly. That's actually exactly what's going to happen, so here we go. I just want to say thanks so much to the Founders Conference here just for even starting this whole thing, the committee for taking in, doing all the review on all the talks that are submitted, the staff that actually get everything done, Allison and everybody who's working on streaming everything, and really thanks to you guys for coming here. It's the first thing in the morning, and it's not lost on me, so I really, really appreciate it. So I'll tell you a little bit about myself. My name's Andrew Morris again. My background's actually in offense traditionally, and in security research. I was on the R&D team at Endgame for a little while, and then prior to that, I was doing security consulting for a couple of different consulting shops. My Twitter handle is just Andrew 3_ and Morris, and then that's my email. So basically, what I'm going to talk about is lots of people scan the internet. I built a system that collects all of the internet-wide scanning activity. I'm analyzing that data to find weird stuff, and I make all of that data available to you for free via an API. This is the structure of the talk that I'm going to go through. Basically, I'm just going to give a little background of what's going on, some history of why I'm doing this thing, why I built this thing, what I'm doing now, some kind of previous work. I'm going to do a big kind of technical deep dive on the architecture of the system. My goal is actually for everybody here to be able to walk away from this talk and build this whole thing themselves from the ground up, and not make any of the same horrible mistakes that I made building it the first time. I'm going to talk about some of the analysis that I've done. I've spent so much time building this thing that actually I've not done a tremendous amount of analysis because I've spent so much time just trying to get the thing up and running. Some future plans that I have for this same kind of thing, sort of a conclusion. Then I'm going to take questions at the end. And if at any point you have questions or comments, or if I say some bullshit or whatever, you can just raise your hand and we can just have we can talk about it right in the middle of the talk. It doesn't bother me in the slightest. So now, in 2018, I guess, internet-wide mass scanning is easier than it's ever been before. And I attribute this to basically three things. Open source tooling with things like Masscan, ZMap, Unicorn Scan, et cetera. Cloud computing, where you just got these servers that you can stand up on the internet that have recyclable IP addresses. And high throughput internet connections are faster. So what's internet mass scanning? Mass scanning is basically, instead of scanning, doing a port scan on one box for maybe 1,000 ports, mass scanning is actually iterating through all of the IPv4 or some of the IPv4 space from 000 to 255, whatever, give or take a few blocks. So it's 4.2 billion IP addresses. And data-wise, with the size of a SYN packet, if you actually multiply that out, bandwidth-wise, it's about the same as uploading a 240 gigabyte file. That's an easy way to think about how much bandwidth it takes to mass scan the internet. Of course, there's a lot more complications with networking gear and your internet service provider and all kinds of other things, but that's essentially what mass scanning is, right? So what does this actually mean? Well, this means that lots and lots and lots of people are scanning the internet now because it's insanely easy. You can do it super fast, and there's a number of different good and bad reasons to do it. In terms of the good known actors who are doing this, you've got Shodan, who's OG scanning the internet. You've got Census, Sonar, Shadow Server, and you've got some others. A lot of organizations like these ones are nice, and they advertise who they are. And then there's a lot of other ones who do the same thing. They just don't advertise who they are, but they're doing the same thing. And then there's a lot of evil people who are kind of doing the same thing, but for malicious purposes. So when you just spin up a box on AWS or whatever, or connect your computer directly with a routable IP address into the wall or something, and you were to like pull up a sniffer, you would see traffic hitting you, and you'd be like, what is that, right? So this is all this mass scan traffic. So this has actually created somewhat of a problem for some people, for some organizations, not all organizations, but for some organizations, which is when you see an IP address that is scanning your network, are they scanning you specifically, or are they actually scanning the entire internet and you're just part of like that background fallout that's seeing it, right? And even further, if you see like an IP like attacking you, like slinging an exploit or brute forcing an exposed authentication interface, are they attacking you? Are they attacking your network? Are they out to get you? Or are you just part of some background fallout of them doing this kind of in every which direction? It's hard to tell. So my proposed solution was basically, okay, like let me just collect all of that noise, all of that omnidirectional background traffic, all that scan traffic, all that attack traffic, everything that's untargeted, and let me actually subtract that from like what you're seeing on your side, and what's left should be things that are only targeting you. That's basically kind of the mindset that I had sort of going into this. So how do I actually plan on doing that? I just stand up a shitload of servers in a bunch of different data centers around the world and a bunch of different regions of different data centers in the world, and I instrument all of these different servers with extremely aggressive logging IP tables rules that log every single packet of every single port of every single protocol, no matter what. So no matter what hits it, it creates a log of everything. I stream all of these logs to a centralized place. I do some analytics to actually convert them into like a consumable format, and then I put them in an API so that you can eat it. And basically the thing that you have to keep in mind that has sort of come to my attention after I've been paying attention to this for way too long is that basically it's just strategically a lot easier to ask a question of the internet than it is to answer the question, to know the answer that somebody's looking for. So it's easy to scan the internet for X piece of software. It's hard to say who is scanning for X piece of software. It just requires a lot more work. And so the byproducts of like building this system that I'm talking about right now is that you can see changes in internet scanning over time. You can see upticks, and you can see all kinds of other things. You can, if you have this data, you can actually opt out of being scanned altogether, which is, there's some kind of ethical stuff in there, whatever. And you can also you get a lot of information on malware campaigns as well, which is not why I built this particular system, but it's a cool byproduct of it, which is nice, I guess. A little bit of history of this system. I did a similar talk I did a talk in the same vein, actually in this room right here, like 3 years ago, and that was Animus, kind of like version 1, and it was bash and glue. It was really, really shitty. I did some related work at a previous company that I did for some stuff, and then I had kind of like this epiphany in 2016 where I was like, the data that honeypots collect sucks. Like, it's not good at all. It's the opposite of threat intelligence because like literally everybody sees it. It's like anti-threat intelligence, right? It's bullshit. It's all the shit that everybody gets on their entire network. And so then I tried to kind of do this with a startup, and then I realized that startups are insanely hard, and then I did the exact same thing again. And so then, I don't know, after this, I'm just going to quit this industry forever and become a monk, which leads me to Gray Noise, which is this thing that I built, right? So I'm going to just throw this whole thing out here. I've been working on it for a really long time, and if you like it, then that's awesome. And if you don't, then that's still awesome. So I'm going to do kind of deep dive on the architecture of like what this system actually looks like. There's basically 3 core components of it, which is collection, analysis, and consumption. This is like my military-grade PowerPoint skills at like the architecture of the whole thing. So step 1 is you just need to stand up a bunch of different servers in a bunch of different regions and a bunch of different cloud providers, right? Easy. That's this piece, right? Okay, so to orchestrate all of those, your 2 best options, in my opinion, are going to be Terraform, and then I don't have it on the slide, but libcloud. So Terraform is actually a tool by HashiCorp written in Go. It's open source, and basically it supports a bunch of different cloud providers. It's kind of like cloud provider agnostic, and so you can use it. You just punch in API keys, and you just say like, okay, like put up 10 servers that do this thing, and bootstrap them with these scripts or whatever. And it's really easy to use. It's a command line tool, and It's not really, I don't actually know how to use it as an API, which is why libcloud is a lot more handy at times, because libcloud, Apache libcloud is something that does basically the same thing, but it's a library. Some lessons learned, and I'm going to be following kind of this same trend the whole time that I'm talking, where I'm going to like kind of divert off and say like things that I screwed up, and if you want to build something similar for any reason, then don't make the same mistakes that I did. So the first thing is like when you're spinning up a bunch of servers on lots of different cloud providers, there's this thing called like Cloud Init, which I didn't realize that is installed on some cloud servers and not installed on others. And basically it's kind of like a bootstrap process that you don't want to do anything on the server until it finishes. And if you do, you're going to get some weird like random errors that are going to feel random that are basically race conditions. And so if you want to figure out if Cloud Init is running in the provider that you're running on, and if it is, you want to write something in your bootstrap scripts that wait for that to finish. Some cloud providers give you NATed IP addresses with the boxes and some don't. And that's something that's very important that you need to know when you're kind of like instrumenting all this. And the interface names are just completely different in all of these, right? So some people give you an ETH0, some people give you an ATH0, I mean, whatever, right? So then the next step is you need to have like things on those servers that are actually producing log data, right? And so like I said, I wrote these like ridiculously aggressive IP tables rules that say literally anything that you give me, I'm creating a log for. I don't care if it's ICMP, I don't care if it's UDP, like whatever. I'm creating a log for everything, right? And then I output that to, I have that instead of going to syslog, I have it output to a separate file in a different folder. Separately, I also have some like microservices that are just like barely, they're not honeypots. Like they're literally just there to like collect like low interaction data. So like things like SSH authentication, attempts, Telnet, HTTP, and a couple other ones. So if you're going to use IP tables and POF or sniffers or whatever, you need to make sure to tune them so that you ignore everything that's outbound from your box. You don't want to log anything at all that's outbound from your box. The other thing that you want to do is you want to make sure that the cloud provider that you're operating in doesn't have any kind of automated health checks that are going to come from internal IPs, or even there's some other weirdness that'll go on. Google does this. There's a couple other ones that do it too. You will see spoofed traffic is another thing that you should be aware of, is when you are just doing like you're looking at SYN packets or UDP stuff, you will see spoofed traffic. That's a pain in the ass to deal with sometimes, because basically like if you rely too heavily on just extremely low interaction like SYN packets, like I see SYN packets from 8.8.8.8, right? Google is not scanning any of my boxes. This is somebody that is just spoofing that. So you need to be aware of that, and you need to know that there's things that you need to do to have more fidelity in things like completing a three-way handshake, etc. And in terms of best bang for your buck, if you want to stand the same thing up, and you don't want to go through the hassle of like writing a bunch of like little microservices, the best thing that you're going to be able to, the best bang for your buck is going to be IP tables, HTTP, Telnet, SSH, and POF. POF is very, 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 very useful. Step 2. Take all of this data and stream it to a central place. That's this RabbitMQ right here. So RabbitMQ is just a message queue. It has topic routing. Looks like this. Basically, you want to, this is just something that lets you kind of like stream data or like write data to a bus to other different places and route it differently. And it's pretty robust, and I like it a lot. Some lessons that I've learned is I tried doing this with Google PubSub first, right? Which Google Cloud is the shit, and PubSub is awesome. But if you're moving like 200 messages per second, and Google PubSub charges you by the message, so like your bill is going to be astronomical. So just be aware of that. You're going to want to make sure to like maintain, if you have like a log forwarder of something that is like shoving all these things off to a RabbitMQ, you want to make sure to maintain state of the last things that you saw in that log file. And it's also really nice to build like a little meta message envelope when you're looking at logs and wrapping them up and zapping them off to a queue, so that you know like what time you did it, what provider they were in, what region they were in, like a UID of the node that they came from, etc. And then other possible things that you could use instead of Rabbit, or things that I've thought about using but that I haven't done before, is things like ZeroMQ and Kafka, which would be obviously different from a queue. Would be like stream processor. I also wrote a little piece of software called StreamD that basically just eats a bunch of logs and like shits them into a database, which brings me to my next point. You have to have things eat out of your RabbitMQ. So step 3, put in a database. So I've got like a little cache and database. I use Postgres for this. Postgres is like this frickin' Swiss Army knife of databases. You can use it for anything. It's not necessarily the fastest, but you can absolutely use it for anything. It's the shit. So like basically I've kind of a Postgres cache of everything that's coming in for like the last like 4 days or whatever. It's like kind of a rotate in and out thing. And I take it and I just stream into that. And then I do kind of batch analytics on that. I'll get into that in a second. And then you want to make sure that you have a dumpster. The dumpster is basically you want to have something that's reading from your RabbitMQ and just basically, or from whatever the bus is that you're using, and you want to just read from that and just cram it into long-term storage and compress it or whatever because you want to make sure you never lose anything. So, like I said, Postgres is awesome, but it can be too slow for data this big. I mean, if you don't have like a fat Postgres cluster or box to put it on. Google BigQuery is also awesome, but it is like it gets expensive if you're going to do like batch queries on it over and over and over again. So, in my opinion, Postgres and Cassandra together are perfect for basically if you have like doing complex queries in Postgres to like line things up, and then just taking exactly what's in Postgres, picking it up, and then plopping it into Cassandra, where you can then query against that. And Cassandra is stupid fast, but it is just a real pain in the ass to deal with in terms if you don't like understand like the data models and all that stuff. So it'll really screw with you. This is a sharp learning curve there with that. I have like the next thing is you want to enrich the IP data on the way in with things that are relevant. So step 4, enrich the IP data. You want to have things like as you're collecting IPs that come into the internet or that come in that you see in your pipeline, you want to make sure that you have things like ASN, RDNS, organization, whatever. On the way in as you're loading stuff. So basically, I've done a lot of different things with this. I tried collecting those enrichment. I tried just being a cheap bastard and just collecting all that data myself from like RN and the other ones, and it was really just a big pain in the ass. So I kind of bit the bullet, and I got a ipinfo.io subscription for like I think I'm at something like I get an average of like 70,000 unique like IP lookups per day, and then I just kind of cache them for a little while. So it is nice though. RN has an unauthenticated, non-rate limited public API that you can use for looking up IP data of anything in RN, which is really useful, like organization lookups, etc. So I built like a little teeny tiny service called EnrichD that basically just takes an IP address and it just kind of gives you all the IP enrichment of that, and I use that inside. And then another thing, like I have a little stupid Wu-Tang Clan joke in here, but so like if you have like an HTTP request that happens that has to happen 200 times per second or whatever, like that's really slow. Like even if you do it super super fast and you've got it down to like 100 milliseconds or something like that, then it's still going to add like a massive amount of latency to your pipeline. So just cache things like as frequently in as many places as you possibly can, because everything's going to be a lot faster, a lot more smooth that way. So step 5, once you get the data like loaded into a place, you want to analyze it and categorize it and tag it so that you like basically start actually identifying what all of these different things are. So that's this place right here. So this is a service that I built called AnalyticsD that basically chances are, well, I'll get to that. So you want to analyze like some little period of data, like the last 3 days or 4 days in that little temporary Postgres cache that I was referring to before, and I want to catalog things like let's look at let's catalog Shodan and Census and Sonar, and then we also want to catalog activity. So those are actors, but we want to say like, okay, what are they doing? What are they scanning for? Right. So this is a lesson that I've learned from several people. In a short order, when I was asking a bunch of my friends, like, hey, how do I do streaming analytics? Like, how do I write like a streaming rules engine and blah, blah, blah. And like everybody basically told me like, don't. Like for this, you don't need it. And then everyone's like, do you need real time? Like, do you really need real time? Like, no. And so, then from there, it's like, okay, well then just do kind of really quick batch and like batch queries and something just kind of constantly on a short window. Chances are like, with something like this, and actually probably 9 times out of 10, you don't really need any analytics that you do to be real time. Like they can lag by 5 minutes. It's not a big deal. And so another lesson that I have is like you really want to make sure that when you have a bunch of nodes on the internet that are collecting data and you're doing you're tagging things, you want to make sure that all the activity that you look at, you want to basically say, like, did this happen on more than one node across my little farm of nodes out there? Because if it doesn't, there's some weirdness that you can run into where there's like stale IPs that are talking to a box that they thought was something else at some point. That's neither here nor there. And then basically you need to know for like mathematically, if you want to do like time series analysis or anything like that, it's very important that you know exactly how many nodes you had up at any given time. Because if you have, let's say, for example, 10 nodes that are up, 10 servers that are up that are collecting this data, and you increase that to 12 and you don't document that somewhere or you don't have a record of that, then everything's going to spike up. And you're going to be like, oh my God, like this is, everyone's scanning the internet 20% more. And obviously that's not how that works, right? And so then the last thing is like make the data available, right? Step 6, make the data available. That's this little web API right here. So consumption, like here's this API. This is public right now. If you want, you can just go on GitHub and you can search Gray Noise API because I didn't want to like say the URL, or I guess I didn't want to write it either. But just search Gray Noise API, and it's right there. It's free. It's unauthenticated right now. It's not going to be unauthenticated forever because people are murdering my API right now, and I can't handle this anymore. So I'll probably do an update here in the next few weeks where it will be authenticated, but it'll still be free. So you'll still be able to do all the same crap. But I need to be able to cut people off. I need to. So then also some people have written some really sweet bindings for the API already. So there's on GitHub, Bobby Filer wrote a Python integration called Gray Noise. Tech, I don't know, that's his handle, wrote something called PyGrayNoise. Bob Rudis wrote some R bindings, and somebody wrote some Go bindings. I don't actually know who, but I found it on GitHub, which is sweet. I'll actually update the slides with the actual URLs, but I didn't have internet when I was writing this slide. And then, bam, surprise, holy shit, I have a front end now. Somebody built a front end that was insanely awesome. So Casey Buto, he's at GitHub CButo. He built like a front end with Angular that I actually put up. I didn't write a single line of this code. I don't own it. It's open source, but I put up a copy of it right now at viz.graynoise.io. It is not mobile friendly. But this is basically what it looks like. And basically you can go through and you can kind of click things and see. If for casual browsing of the data, you can kind of go through and click through the tags and you can sort of pivot on IPs and see what other tags are relevant to it. So I'm actually really, really, really excited about this. So a really big consideration for this is OPSEC, is operational security, right? So when you're standing up a bunch of these nodes that are going to be collecting scan data, at some point, if you actually talk about it like how I'm talking about it right now, like people are going to take interest, bad guys are going to take interest in avoiding you, right? Doing like, they don't want you to know, they don't want your IPs to be in the pool of things that they scan. They want to exclude them, which means they want to fingerprint them, right? So OPSEC is important. You want to not be reliably fingerprintable, or really, you just want to make it as hard as humanly possible. So if you have the bandwidth to write custom services, just from a game theory perspective, you're gonna go far with this because security through obscurity isn't really real, but obscurity through obscurity is absolutely real. So you want to write you can just write. You can write stuff in Twisted. You can write stuff in a lot of different languages have just bare bones language protocol support. If you want to just have an SSH service that just craps out authentication logs, whatever. You want to make sure to encrypt everything everywhere, right? You want to just make sure that your bus is encrypted. You want to basically make sure that the box, all of the nodes, are as untrusted as it possibly gets. They probably won't get popped, but in case they do, you want to make sure to make sure that the damage is as little as humanly possible. Don't use your own efforts names anywhere inside of the box, just for OPSEC purposes again. You want to use ops domains that are not the same as so for example, my domain is graynoise.io. You don't want to use postgres.graynoise.io, or you don't want to use node1.graynoise.io. You want to make sure that you use separate ops domains for everything. Dockerize all of your services if you have the compute for it, which you won't really have the compute for it if you do the smallest node size of a lot of the different tiers. It'll add a little bit of overhead, but it's not really a big deal. But if you Dockerize stuff, then even though they say this isn't for security, like it's going to be a bitch and a half to break out of a Docker container. So like Dockerize all the different services. This is something that's really that'll take you really far. Shift the infrastructure constantly. So if you actually automate the deployment and the orchestration of all of the different services, then it's trivial to bring them up and put them down. So there's no reason for you to not just constantly have some section of them that are just going down, standing back up. And you're just going to make bad guys' lives a lot more miserable, because a lot of the times what they're going to do is they're going to be like, aha, I found this, or Shodan, I found this, I found a way to fingerprint this thing, maybe. Like, okay, go to Shodan or whatever. And if you're shifting it around, once a week or whatever, then it's like, you got to go back and do all that again. So, or they automate it, and I don't even want to get into that. But anyways, so this is, the last thing is reduce the Oracle surface. This is kind of weird. So basically, anytime you have a system that takes in data from a place and then puts out that data that's accessible to the internet, and you don't want people to know where the locations of your collection is, and they have some kind of I/O capability. This, I don't actually know what the real term for this is, but I've always used the term in Oracle. If I were to expose the raw data that I see, and somebody were to write like a mass scan plugin to issue like a unique identifier, to issue a GET request to a unique path in an HTTP server, or to like a weird port with some weird flags set, and every single box that they scanned with this on the internet was something completely unique, and then they went back and they searched for those paths that they found, and they see the things that came back, they have now identified all of your infrastructure, right? So this would be like an Oracle. So basically, it's hard to kind of like OPSEC around that. So if you're doing kind of like analytics, you want to make sure to have some mushiness in there, so you're not necessarily just taking the exact data that they're giving you and putting it right back out. You need to kind of think it through the whole way to make it kind of as difficult as humanly possible. One of the ways that I would recommend that, actually, there's some timing attacks we can get to. I'm not really going to get into that right now. But like the minimum, one nice thing is like don't ever display anything back to the user that has happened on less than n number of nodes or whatever, because then it becomes computationally, well, I guess bandwidth-wise, like way more expensive to actually get that done. And if things are shifting around, then even more so. So anyways, just food for thought. So then if you want to basically do this whole thing that I just described, like build this entire thing, and you want to just pick out like 5 cloud providers and have one node in every region in every one of them, I kind of built a little map for how you can do that for $400 per month exactly. And so this is so AWS has 15 regions, DigitalOcean has 11, et cetera, et cetera. I got the minimum node price here for all of them. You end up with, actually, hang on, 30, 41, 50, 86 boxes with this plan. 86 boxes out there, $400 a month. You can't beat those numbers. Basically, the only thing is I have some notes in here, like there's no ops boxes in here. There's no databases with these considerations. So, but this is just, and you also won't have nearly enough coverage to do this like really accurately. And also you can save money by just like buying extra IPs on these boxes with some of the IP, with some of the cloud providers, but it complicates engineering a little bit. But basically, so like if you do want to do the same kind of thing, this is kind of ballpark of how much you can spend for doing it in a reasonable way, and you'll still get some pretty good data and some pretty good coverage. This is the part that I'm really excited about, even though I've done it the least of everything, the analysis. So I want to talk a little bit about like what I'm collecting. I've already kind of gone into that. I might just skip that. Like a summary of kind of the volume of data that you would see with the exact size. So my project, Gray Noise right now, it used to be, at one point, it was very close to the size that I just described. It is no longer. But basically, like I can go through and I can tell you exactly how much data you're going to see on average if you do that, even between the different services, et cetera. So I'm going to do that in kind of volume summary, the data summary of like what things actually look like. I'm going to talk a little bit about just things that I have observed, actors that I have observed, malware that I have observed, my hall of shame, which is basically like the shittiest areas of the internet where just like there's all this just disgusting malware that's just attacking everyone all the time. I'm actually going to do the exact same thing, but I'm going to do kind of like, and I'm not going to be like, I'm not trying to be too much of an asshole about it, but like basically the cloud providers that have the most malware in them that just don't do a goddamn thing about it. And then I'm going to talk about, I'm really excited to talk about my weird shit section, which is basically just strange, unexplainable things that you see when you start measuring all the omnidirectional scan and attack traffic of the internet, as one does. And just some various different lessons that I've learned kind of along the way of doing this. And also just by happenstance, I'm going to talk about JA3, and the next talk after me is the developers of JA3, and they're going to be talking about that. So I would explain it to you, but if you want to know more about it, just keep sitting down, and the authors will explain it to you. So basically, like these are the actual data sources: passive one, IP tables, packets on ports, POF, passive operating system fingerprinting. This is the shit. I love POF. Some of the more active things would be like HTTP, SSH, Telnet, and then some experimental ones like RDP, SIP, blah blah blah. I actually, this is really lackluster for you guys, and I'm really sorry that this is the case, but I realized very, very recently that I don't actually have a good way of quantifying the top ports that are being scanned for accurately. Every single port, you're not wrong. But if I were to do a top 10, I realized very recently that I've been doing this wrong for years. I'll basically I'll do a SQL query or whatever, and I'll look at it and be like, okay, just show me the destination ports and protocols of the most common hits that I get. Easy, right? Turns out not at all. Because if you've got one person that hits one box 1,000 times, or if you've got 10 boxes that hit the same one box one time, or if you've got one box, or if you've got 100 boxes that are hitting one box, and it's you actually have to put a lot more thought into it, and I don't have the answers for that yet. And I don't want to tell you something that's bullshit. So I'm going to revisit this because it's a lot more complicated than I thought it was to do it correctly. HTTP, you just see a lot of people asking about slash, spoofed user agents, search engines, crap like that. See a lot of SSH, telnet bots, business as usual, same shit. And then POF, you see it's actually pretty good visibility of operating systems and who's scanning shit out there. So some of the volume, again, with $400 worth of servers, you're going to see 1 to 2 million IP tables events per day, 700,000 SSH logins per day, et cetera, et cetera. Kind of key takeaways here: you need to be ready to deal with 100 to 200 messages per second through your queue, up to probably about 300 to 400 at times. You're going to see about 60,000 new IPs per day when you do this, and it's going to end up, if you smash all your records together in an effective and efficient way, and you compress them, you're going to end up with about a gigabyte of compressed data in your dumpster every day. So these are some of the actors that I'm actually seeing. You've got Shodan. This is actually an exact breakdown of how many IPs all of these different benign actors are that I have. The text is a little bit small here, unfortunately. But Shodan scans from 27 IPs. They've been scanning from 27 IPs. Census scans 334, et cetera, et cetera. Some of this is more interesting than others. Netcraft is interesting because their stuff just kind of goes up and down, and it's a little bit hard to track, to be honest. And then there's some of the malicious stuff, like Mirai. So these botnets are just hilariously huge, and they're just popping everybody. I mean, I don't know, but so that's a talk in and of itself. So kind of my hall of shame a little bit. There's this Brazilian ISP that they just have. I think just every single router that they have is compromised, and I'm not kidding. There's so many. It actually, I think, is probably more common for them to be compromised than not compromised. So there's. And I think they actually know about this, and I think people have warned. Somebody tweeted at me I've warned them about this, and they don't do anything about it. So whatever. So basically, this is just places where there's basically telnet worms and SSH worms by count by IP. This is how many there are to each of these organizations. It's just kind of interesting to me. Brazil really needs to get their shit together in terms of ISPs and not having bots that are just kind of screwing everything up. The ISPs really need to kind of take a deep look inside on that. And then, there's some other like less interesting things in here. The cloud ones that I was talking about, this one's a little bit harder because these are, and it's actually the same for the last. There's varying sizes with a lot of these. So like, AWS has 700 compromised machines over time, but like they may also have the most IP space, et cetera. I'm really excited about this. So, this is just a lot of the weird stuff that I see. And this is the stuff I'm very, very excited about. You see a lot of people on the internet that are like scanning the internet that are pretending to be things that they're not, right? So if you look at like all the user agents, you'll see like a lot of like, oh, I'm Safari. It's like, are you? Are you Safari? So if you have like boxes that have no business value whatsoever, the only things that are going to be coming to them are going to be omnidirectional scan traffic by definition, by design. No one opens up their Chrome and they're like, you know what I want to do? Like type in a random IP address and just see if it works, right? That makes no sense, right? So you're going to see like a bunch of people like, oh yeah, no, I'm definitely Firefox. And you're like, you're not Firefox though. And then you're going to see some other really interesting stuff like where they'll say like, oh, I am definitely, it's like Safari, but the POF fingerprint will say like, no, you're definitely Linux. So you're definitely not Safari. And then you can actually keep doing the exact same thing with J3, which is why I'm super amped for the next talk, which J3 is like a tool that fingerprints SSL negotiations pretty reliably. And so it basically just turns like an SSL connection into like, oh, it's like a fingerprint that whenever the same program somewhere else does the same thing, it would have the same fingerprint. So it's kind of like client negotiation fingerprinting, which is really interesting. Dangling DNS. This is weird. So basically what happens is sometimes when you spin up a bunch of IPs up and down on the internet constantly in cloud providers, it's not uncommon for you to actually get an IP address that used to belong to somebody else and still has domains pointing to that belong to them and still has traffic that are trying to browse to those domains that are then coming to you. And so basically like I've spun up boxes before that just immediately start getting slammed with traffic. Like immediately, and I'm just like, what is going on here? And like then you'll like look at like maybe the host parameter of like what's coming in, and you'll be like, this box, there's a DNS record pointing to this box that I just stood up, and it's stale from whoever owned that IP address like at some period before you. This is dirty traffic. You don't want this traffic. This pollutes your data set because those are not IP addresses that are scanning the internet. That's probably stuff that's trying to get to like legitimate resources, and they just happen to be coming to you because the person who owned the thing before didn't really have their shit together. How big is that opportunity right there? So hang on, can you repeat the question?
Like, let's say that I wanted to get traffic from whatever.
Okay, yeah. So the question is like, how big is this opportunity? I've actually thought about this before as an attack surface, and somebody has done a blog post about this. I hate that I can't remember who it is, but if you search like, I don't know, I'll get back to you. Basically, like the attack pathway would be like, what would happen if, and I've talked to a couple of my friends about this, what would happen if you just iterated through as many IP addresses as humanly possible in AWS, you stood up a box just long enough for it to tell you what IP address you were going to get, and then you were to figure out like, are there any DNS records that are pointing to this, which that's hard in and of itself, or just long enough to have like a web server go up and then introspect and look at the host parameter of everything that comes in. You could totally do it. It's just so unpredictable that you'd never be able to target it. And I mean, it would be hard. And then what you would be able to do would be a little bit limited. Maybe you could cut like a Let's Encrypt cert. Once you get an IP address that belongs to like something like akamai.com, for example, or whatever, like you might be able to cut like a valid SSL cert at that period of time. I know there's a blog post about this, and they definitely talk about it better than I do. But it's, like I said, it's weird shit. The worm finder, this is a really cool new thing that I'm doing right now, where basically like Gray Noise observes IP addresses that fly across that are scanning ports. I just started doing this thing where whenever an IP address is scanning the internet for a port, I just turn right back around and I look at that port and see if it's open on that box, right? A lot of the times it's just like somebody scanning for port 80. They also have a web server. Who cares? Not a big deal. But a lot of the time, it's like somebody scanning the internet for some really weird port that I've never heard of before, and then I turn back around and they're also running that. They also have that port open on that weird service that I've never heard of before. So that may sound kind of innocuous, but if the answer is yes, if somebody's running the same software that they're looking for, why would that happen? That is very wormy behavior. Anytime that somebody's like, yo, are you running this piece of software that I am also running? Like, that's what worms do. And so I actually started crunching this, and I noticed that basically there's the average is it's about, and it clusters pretty closely together, about 4 days where there's a lot of these boxes that'll scan the internet for a thing, have that port open, and then 4 days later either stop scanning for that thing or stop having that thing open. So anyways, you can find a bunch of malware doing this, or a bunch of maybe malware doing this. The next thing is like ZMAP, the scanner that I talked about earlier, has a hard-coded ID flag parameter. Shout out to Oliver Gasser at the Technical University of Munich for like queuing me into this. But basically, anytime you scan the internet with ZMAP, and it's not necessarily a big deal, but everyone knows that you're using ZMAP because ZMAP hard codes the ID parameter of the TCP header to 54321, making it trivial to fingerprint it, right? Unless you can go to GitHub to their repo and just literally Control F 54321, and this basically allows you to fingerprint it really easily. It's kind of an OPSEC oversight. No, I mean, I know it was intentional on their part, but it's an OPSEC oversight for people who use it and don't know that everyone knows that you're using it. There's still a hilarious amount of Windows worms out there that are just opportunistically scanning on port 445 for SMB and like slinging configure and stuff like that. Like a hilarious amount of them, like hundreds of thousands of them, millions of them, I think. And so I gotta go back and check. Basically, I'm starting to see an increase in RDP worms as well, but these aren't like slinging exploits. They're just brute forcing credentials. If I were a betting man, I would guess that WinRM is going to be next. And that's, I mean, it's not good or bad. It's just how it is. People do really weird stuff through proxies. So I started doing this really kind of, this thing where I would stand up a bunch of boxes and I would have like an unauthenticated proxy. That's a horrible idea. Don't do this at all. And then I started like whitelisting it because like shit got weird. And then basically a lot of people like pass, like you'd think like, oh my God, it's going to be like some super elite traffic that's going through. What you end up seeing is just a lot of people scraping airline pricing data because this is actually like highly competitive in a lot of markets where like, you know, company A has, they want to sell their plane tickets for $1 less than the other person so that they show up before and thing. You also see credentials passing through and you see people trying to pass stuff through the API servers. And you also see people trying to get to news sites from foreign countries. I don't even want to dig into that yet. So SIP boxes that you have like VoIP servers, like you will see people trying to make phone calls with them. And I have this theory that people, a lot of like the robocalls that come through are probably from compromised like VoIP machines on the internet. I have not proven this theory yet, but it's just a hunch. People scan through weird shit through Tor. So like I fingerprint Tor nodes and basically like that's the same kind of thing where I'd be like, oh, you know, I'm sure they probably do some really sexy stuff through Tor. It's like always people doing like scanning SSH, whatever, worms, and then like industrial like Siemens industrial like SCADA systems and stuff. I'm like, oh, that's terrifying. And then like also a lot of people scanning for like cryptocurrency miner software, which is also weird. And then this other thing that's kind of like a theory that I've had for a while that I haven't actually proven yet, but like I've been thinking about it. You can probably blow up worms, like compromised machines, by just listening to all the shit that they do, like collecting all the usernames that they authenticate to you with, and then turning right back around and authenticating right back to them with those. Because chances are, if like a machine is like has that malware installed on them, and I don't know, I mean, like they probably use one of those passwords. So I haven't actually done that yet. Well, I won't do that. That's very illegal. But I'm sorry. That's what. Anyways, just a thought. And so basically, that's kind of the end of my like weird shit section. Just real quick, like what is like the next thing that I actually want to do here? My version 1.1 API is coming really soon. It's going to be authenticated, but it'll be the same one that you know and love, and I want to have some extra endpoints that make it easier to kind of explore the data. I want to integrate with everything so that anytime any tool or any piece of software or any SIM or any like whatever is showing an IP for some internet activity, I want it to be basically be able to say like, oh, this is in gray noise, like this is this thing, like this is probably not a big deal, or this is probably like, just be aware that this is happening in every which direction. There's a lot of really cool ML opportunities for some of the data that I'm collecting. For like time series is not ML, but like there's a lot of really cool things that I think could happen here, especially from like fingerprinting protocols, et cetera, and like clustering things together, like clustering like operating system fingerprints together. And I actually wanted explore the idea of doing this same thing with things that are not internet-wide scanning, like things like intranet traffic, like inside of networks, like collecting noise inside of networks, like doing the same thing with like traffic that goes into and out of a network, just like fingerprinting like all the things that you should see, they're expected, and kind of like same sort of idea of files on a file system. That's a little weird. I don't know about that. And then basically, I mean, that's it. The internet's noisy. Every packet has a story, whether you kind of think about it like that or it's packets don't just fly out of nowhere, and there's a shitload of them. And so basically, like, it's really interesting. Every single one of these, there's a reason for every single SYN packet that hits every single box on the internet. There's a reason for all of them. It is possible to collect all of this background noise, and I do it right now. And if you want to explore the data, just hit the API. If the API doesn't solve your, like, if you want to do something that the API doesn't let you do, which is very possible because the API has like 2 endpoints, just hit me up and I'll give you the data set, and we can do cool stuff together. And yeah, you can get me on email or on Twitter. Is probably the easiest ways to do it. And that's it. Questions? Yeah, right there.
So how would you compare what you're doing versus what you could do with data from SANS and
That's a great question. So the question is, how would I pair what I'm doing with what the data that SANS Internet Storm Center is doing? I don't know the process of how they collect their data. I don't know what their backend looks like. They're kind of a little bit of a black box of like how they actually do the collection. I have a feeling that we're collecting a lot of the exact same stuff. So honestly, I would just probably, the first thing that I could think of would be just to match up time series like upticks to see like, I see this thing, did you see this thing? And if the answer is yes, then like, okay, then we're good here. But otherwise, like, we're doing remarkably similar things. They've just been doing it for longer, and they're a little bit more of a black box than I am. Any other questions? Yeah, right there.
Yeah, have you done anything with IPv6?
Have I done anything with IPv6? No, but funny enough, 3 years ago, like today, somebody asked me the exact same question. They were also sitting in that exact same chair. That's yeah. So I am not doing anything with IPv6 at all. I've seen IPv6 packets before, and I have not gone back to really investigate them. IPv6 mass scanning is a very strange thing. More on that, I think, later. Thank you. Good question, though. Right here. Yeah.
You mentioned that you did some lightweight microservices to do like SSL handshakes and stuff. How far down that rabbit hole did you decide to go? Like, how do you know how much handshaking is right?
Sure. So the question is, I mentioned that I do SSL handshake identification and analysis. How far down that rabbit hole did I go? So what I'm doing right now is I'm just collecting. I have my HTTP services that I wrote, my microservices that I wrote, also have HTTPS services on certain ports. And so when somebody establishes that SSL handshake with me, I'm skimming that right off, and I take that, the JA3 fingerprint that it produces, and I cram that into a database somewhere. That's all I'm doing. I've tried actually labeling as much of that data as possible. JA3 provides a set of labels as part of their GitHub repo, and I want to make that even bigger by fingerprinting like mass scanning tools and library, like client libraries, etc. So and does that answer your question? Awesome. I've got the data still, so I mean, I want to dig into it more. I just got the stop. Thank you guys so much for coming to my talk. My name's Andrew. I really appreciate it. Thank you.